All right, welcome to Math Minders Academy. If you are just joining us for this first time and you are yet to subscribe to our channel, we urge you to hit the subscribe button right away. Click on the notification bell icon and let's get in together. Guys, go to the comment section after this video and tell us how you feel about this video. Share this video so that other students will have access to it. And so this is a continuation of a video we have made in the past, IGCSE Paper 2.1. We've made a video that covered solution to questions 1 to 13. And we are really excited that the volume 2 is out. This volume 2 covers questions number 14 to number 23. And guys, this video is a boom. All the explanations you need, all the details that the examination body wants you to take note of are very well illustrated and explained in this video. So I hope you're excited to ride with me together. Let's go. Now we are on question number 4. Two solid steel statues are mathematically similar. The smaller statue has height 12 centimeter and the larger statue has height 15 centimeter. The larger statue has a mass 2.5 kilograms. The density of steel is 8 grams per cubic centimeter. Calculate the volume of the smaller statue. And here we are given the relationship between density, mass, and volume. So we are told that density equals mass divided by volume. So how do we handle this very problem? So we are going to look at the solution now. So here we say, let's get their volumes. Let's get their, what you call the volume factor of these solid steel materials that are mathematically related, okay? And so the volume factor is going to be the volume of the small over the volume of the large. And we do not know the volume of the small. We are also going to look for a way using the relationship between density, mass, and volume to get the volume of the large. But again, we know that we can get volume factor if we know scale factor. And of course, since they are mathematically related, the ratio of their length can be used to get the scale factor. And that's what we do here. And so we are told that the height of the smaller statue is 12 centimeter and that of the larger one is 15 centimeter. And so when we take a fraction, 12 over 15, that gives us what we call scale factor. And so how do we turn it to volume factor? We just raise it to power 3. Okay? That turns it to volume factor. And of course, 12 over 15, when you write that fraction in its lowest term, it gives you 4 over 5. That is, if you use 3 to divide 12, you get 4, and you use 3 to divide 15, you get 5, okay? And so we now, proceed to bring this fraction to the lowest form, and that gives us 64 over 125. That is 4 raised to power 3 is 4 multiplied by 4 multiplied by 4. That gives us 64. And 5 raised to power 3 is 5 multiplied by 5 multiplied by 5 multiplied by 5 again. That's in 3 places. That gives us 125. So the volume factor will be 125. Why are we interested in volume factor? Because we are looking for the volume of the smaller statue. So we should be looking at creating a volume factor. And so, how can we get volume of large stature from the given mass and density? We are told that the mass of the larger stature is 2.5 kilograms and the density is 8 grams per cubic centimeter. So with this information, how can we go ahead to get the volume of the large stature? So we are going to see this now, how we can get that. So we are going to consider the volume relationship. That is, volume equals, if we make volume the subject, it gives us mass over density. That formula is key. Volume is mass over density. And so what's the mass of the last stature? 2.5 kilograms. But remember that the density is in gram. So we are changing the 2.5 kilograms to gram. And that means we are going to multiply by 1,000. So we multiply 2.5 by 1,000 grams to change it to grams, because the density is 8 grams per cubic centimeter. Because of that unit, that is why we are changing the kilogram to grams. And so density of large stature is given as 8 grams per cubic centimeter. And we said here that volume is mass over density, and we have mass of the big or the large stature to be 2,500, and we have the density to be 8. And so the volume of the large stature will be 2,500 divided by 8, and that gives us 312.5 cubic centimeters. So guys, we've been able to get the volume of the large or the larger stature. But again, that's not what we are looking for. But that's a passage. We are looking for the volume of the smaller stature. So let's proceed to see how we can get the volume of the smaller stature. So how do we get volume of smaller stature? Let's move to the next slide to see that. And so here we say volume of smaller stature equals the volume factor, which is the volume of the small over volume of the big. Now we have volume of the big. All right. So volume of small, which is unknown, over volume of big or large stature, which is 312.5 cubic centimeter, equals the volume factor, which is 64 over 125. Now, what do you think? Make volume of small stature the subject. If you cross multiply, you get volume of small stature equals 64 times 312.5 over 125. If we clear this fraction, what will be the volume of the smaller stature? Can you guess? If you multiply 312.5 by 64 and divide your result by 125, what would be the final answer? The answer is 160 cubic centimeter, and that is the volume of the smaller stature. That's the volume of the smaller stature. I hope that this explanation is you understand what we have explained here is simple enough for us to be able to assimilate. Okay. If you have any area that you feel is not too clear, you can play this video again and again, and then follow my instruction, follow my explanation. You'll be able to get all the details as regards the solution to this question number 14. So let's move on to question number 15. Question number 15, we are told that students in class P take a test. These statistics show information about their marks. And what are the information we have about their marks? We have the lower quartile to be 38. We have the median to be 53. interquartile range 28. We have the range to be 81. We have the highest mark to be 96. And we are required to draw a bus and whisker plot to represent this information. And so we are going to use what we are given to draw a bus and whisker plot. Can you guess? From what we are given, there are things that are missing, but we are going to look for a way to play around what we are given to find those elements that are necessary to plot bus and whisker, or to draw bus and whisker plot. Okay, so let's move on. Here we said that to draw bus and whisker plot, we need the following 5 items. 5. And what are these 5 items? We need the lowest mark. We need the lower quartile, which is our Q1. We need the median. We need the upper quartile, which is the Q3. And we need the highest mark. We need the highest mark, or in some places we say the maximum mark. The lowest mark can also be called the minimum mark. Okay, these are the 5 items that we need in order for us to perfectly and correctly draw a bus and whisker plot. And so we are given interquartile range. Of course, we know the formula of interquartile range. It is the difference between the upper quartile and the lower quartile, that is Q3 minus Q1. But here, the interquartile range is given as 28, but we are not given the upper quartile. Q3 is not given, but the lower quartile is given as 38. So we plug it into this formula here. 28 equals Q3 minus 38, because 28 is given as interquartile range. Upper quartile Q3 is not given. And then 38 is the value of lower quartile. So we can use this to get the upper quartile. So if we do the arithmetic, you take the minus 38 across the other part of the equation, it turns to positive. So we have Q3 equals 28 plus 38, and that gives us 66. So now we have the upper quartile. Again, we understand the definition of range. Range is the difference between the highest mark and the lowest mark. Highest mark minus the lowest mark, that is range. And the range is given here as 81, but are we giving the lowest mark? Not at all. We are giving the highest mark, okay? But there's no lowest mark. We are giving range, you are giving the highest mark. So we can use the relationship between range, highest mark, lowest mark to actually work out what we need. Here, we need the lowest mark. Range is 81, highest mark is 96. So we do 81 equals 96 minus lowest mark. And so if you make the lowest mark the subject, then you are going to get 96 minus 81, and that gives us 15. And so we have the lowest mark. Okay? I think we have everything we need. Right? I believe we have everything we need. So what stops us from drawing a bus and whisker plot? Let's go. And so right now we are going to use all the things, 5 items that we say are key to drawing a bus and whisker plot. We are going to use them, and we are going to demonstrate how these 5 elements can be used to draw a bus and whisker plot. So let's write them down again. We have the lowest mark, which is 15. We have the lower quartile, which is 38. We have the median, we've got, that is given, 53. We've got the upper quartile, remember, in our previous slide, 66. And we have the highest mark, which is given, 96. So all the 5 items are already got in here. So let's move to the graph now to demonstrate bus and whisker plot. So here, we first draw a line that represents the lowest mark. So you can see that line is passing through where the test mark is 15. It's actually 15 mark. The lowest mark is 15 mark. So that line is drawn exactly on 15 marks, okay? Then the next line is going to be lower quartile, drawn on 38 marks. Lower quartile drawn on 38 marks, okay? The color illustration is also to make it more appealing for us to understand, how easy this can be plotted. And so the median is 53. So along that axis, also along the test marks axis, we look for 53 and we draw a line there, okay, to represent that 53, exactly on 53. Okay, that's a line, in between 52 marks and 54 marks. Okay, we get 53 marks. And then let's go upper quartile, 66. Okay, we draw the line exactly on 66. Okay, and finally, we need a line to represent highest mark, which is 96. And we'll draw that line. You can see that. So all the five items have been well represented now. Okay, so what next do we need to do? What next to make it exactly a bus and whisker plot? We connect this way. Connect this way, and that is what we need. And so, guys, we have been able to draw a bus and whisker plot using the information given. Hope this is clear enough. You can, replay the video again and again to understand. But bear in mind the 5 key elements that we need. And in this question, you are not giving the 5 key elements, but you are giving values that you can work around to get all the 5 key elements required to draw a bus and whisker plot. Guys, if you are finding value in this tutorial video and you are yet to smash the subscribe button, what are you waiting for? Hit the subscribe button, give us a like, tell us something on the comment section. All right, share this video so that other people will have access to it. Maybe, we may not know, a student might be having challenge. This video may be a bailout. So why not share so that this video will go viral and let all that are preparing for exam have access to this video. Let's move now to question number 16. How can we handle that? 15B rather. 15 we've done A. If we go back, let's go back. Okay, so this is 15A. Fine. We have to draw a bus and whisker plot. Beautiful. So let's go to 15B now. The 15B, we are told that students in class Q, another class, take the same test for class Q. The median is 49 and the interquartile range is 35. Make 2 comments comparing the distribution of marks for class P with that of class Q. Of course, remember, median is a measure of average, central tendency, and interquartile range measures spread. So you should be looking at how can I make my statement or build my statement around average and spread. That's what we need to do. So look at the first statement here. I will say class Q scored fewer marks on average. So we are talking about median now because for class Q, the median is lower. For class Q, the median is lower. We are told that the median is 49, whereas for class P, the median is 53. Let's go back. Let's go back. Look at class P. The median is 53. It's higher. Okay. And so when we make comparison with that, we'll say that class Q scored fewer marks, looking at that average, which is the median, because it's lower than that of class P. Now, the next is to use interquartile range, and that has to do with spread. And here is 35. Remember interquartile range for class P. If you don't mind, let's look at it again. Look at interquartile range given as 28. And here for class Q is 35. So higher in class Q than in class P. And so with that, we will say that class Q have a larger spread of marks. Why? Because interquartile range is higher, IQR, meaning interquartile range. So interquartile range in class Q is higher. So they have a larger spread compared to that of class P. It makes sense, right? So that's the statement. Of course, other statements that are similar built around this will also be acceptable. Okay, so this is question number 16. Question number 16. Here for this question, we are given a sphere and a cylinder. A sphere and a cylinder. We are told that the diagram shows a sphere of radius 6 centimeter and a cylinder of height 18 centimeter and radius r centimeter. The volume of the sphere is equal to the volume of the cylinder. Calculate the curved surface area of the cylinder. Give your answer in terms of pi. And then we are given something that can help. The volume V of a sphere with radius r is V equals 4/3 pi r cubed. So how do we actually calculate curved surface area of the cylinder with the information given to us? So here we look at the volume of sphere. We are told that the volume of the sphere is equal to that of the cylinder. So we are going to create equality between the two. The volume of a sphere is given as 4/3 pi r cubed. And here the radius of the sphere is 6. So when we plug in that into the formula, we get 4/3 times pi times 6 cubed. That's the left-hand side of that equation. The right-hand side is taking care of the volume of the cylinder, okay, which is pi r squared h. Unfortunately, the exam body did not give us the formula for that, so it's expected that we should come well prepared and know this formula, okay? So the height of the cylinder is given as 18, but we don't know the radius of the cylinder. So we are going to go ahead to find that. Now, if we make r squared the subject of the formula, if you want to learn how to make a particular variable the subject in a given expression, you can check out some of my videos. I've done something on that. Go to the channel, check it out. You will understand how that can be made possible, the processes, the steps required in doing that. So we get the volume of the sphere as the numerator, and then that of the cylinder except r squared as the denominator. All we do here, there's nothing magical here. We just divided both sides by pi times 18. If you divide the left-hand side by pi times 18, divide the right-hand side by pi times 18. That of the right-hand side we cut out. So we are left with only r squared, okay? Now, with this, you agree with me that pi is common, both the numerator and the denominator numbers that we have there, pi is common. So pi is going to cancel out, okay? And so when that happens, we have 4/3 times 12. How do we get 12 here? Where is 12 coming from? We got 12 by dividing 216 by 18. That will give us 12, okay? So we now have 4/3 times 12, which gives us 16. Of course, 4 times 12 is 48. Divide 48 by 3, you will get 16. And that is the value of r squared. But that's what we are looking for, is the radius of the cylinder. So we take the square root, and that gives us 4. Okay, that gives us 4 positive square root, because cylinder is a length which is measured using positive number. So the radius is 4. Okay, now for the curved surface area, again, we need to also learn that as students who are preparing for exam, the curved surface area formula is not given. So you check textbook before it's part of your preparation, and ensure that these are part of the tools that you should have in your head before you walk into the exam room. So curved surface area of cylinder is 2 pi RH. 2 pi RH. And so we write it 2 pi times our radius is already worked out as 4. And the height is 18. So when we multiply 2 pi by 4, it gives us 8 pi times 18. It gives us 144 pi cubic centimeter. Remember, we are asked to give our answer in terms of pi. So we leave our answer in terms of pi, and that's the final result. Hope this is clear enough. If it is clear and you are yet to subscribe, please go ahead, hit the subscribe button, click on the notification bell icon, so that each time we release a new video, you'll be among the first to access it. Give us a like, share this video, go to the comment section, tell us something. We want to hear from you. Tell us something about this video. Tell us, it may be that there is aspect of this video you want us to improve on. We'll be glad to get a feedback from you. Let's move on to the next slide to look at the next question. Question number 17, we are given a quadratic equation and we are required to solve this, and then show all our workings and give our answers correct to 2 decimal places. How are we going to do this? Of course, once we are given this kind of question and there is an information that your answer should be left to 2 decimal places. So you should be thinking in your head that quadratic formula should be the best approach to solving this problem. So we'll use quadratic formula again. You need to understand the quadratic formula, which is already has appeared here. S equals minus b plus or minus square root b squared minus 4ac over 2a. And so we are going to isolate all the ingredients in this formula, a, b, and c, from our equation. A is the coefficient of s squared, which is 3. B is the coefficient of s, which is minus 7. And c is the constant term, which is minus 16. We plug all of this into the formula, and that's what you have down here. And that gives us everything. So what we are going to do is to clear it out. When we clear it out, we have s equals 7 plus or minus root 241 over 6. Okay, and the square root of 241 is 15.524 and some other numbers. We know we just can't capture all the numbers. Okay, we just bridge it. You can't capture all the numbers. So pick it up to 3 decimal places because we are going to leave our answer to 2 decimal places. So it makes sense to move the decimal number higher than what is required. And so now we are going to break it into two parts because of the plus or minus. So we have S equals 7. We take the first operation, which is addition. So we have 7 plus 15.524 over 6. Or S equals 7 minus 15.524 over 6. Okay? So when we add and divide by 6, our answer to 2 decimal places becomes S equals 3.75 or S equals minus 1.42. That's the final answer. So this is simple enough, straightforward, no trick, no too much thinking. Understand what is required, sort out all your values, A, B, C, plug them into the formula, and you get going. Good. Let's move on. Question number 18. This is function. It has two parts, A and B. Now let's deal with the A part first. We are given a function g of s equals 4 raised to power s plus 3. Okay, 4 raised to power s plus 3. And we are asked to find s when g of s equals 1. If g of s is 1, and then the g of s originally given is 4 raised to power s plus 3. What should be going on in your head? There's a kind of equality that should be coming up. Equality somehow, okay? So if g of 1 is 1, then 4 raised to power s plus 3 equals 1, because we are told that g of s is 4 raised to power s plus 3, and the same g of s has a value 1. That means 4 raised to power s plus 3 should have a value 1. And now, how can we modify 1 to have 4 as a base? We know that when we raise 4 to power 0, it's equivalent to 1. So we bring it in so that we can use the knowledge of indices to bring out the value of s. And so once we have the same basis, what are we going to do? We are going to equate the powers, the indices. We equate them. So we are going to equate s plus 3 to 0. We have s plus 3 equals 0, and the value of s becomes minus 3 when we cross it to the left, to the right-hand side, okay? And so we've been able to find the value of s. That's what is required. So let's go to the B. Now we are to find the inverse, the g inverse of 1 over 16. How do we handle this particular question? So we assign a value, an unknown. We don't know what g inverse of 1 over 16 is. We don't know. So we just say let P equals g inverse of 1 over 16. So since we can't figure out at the moment, we can't figure out what g inverse of g inverse of 1 over 16, we don't know what it is. So assign a letter. And then when you take the, when you take the function, if you allow the function to act on both sides as an operator, it's an operator. If you allow the function to act on both sides, then the inverse and the function will cancel out. A function and its inverse coming together will cancel out. So that's why we now have g of p equals 1 over 16, because we have taken the g inverse of both sides. We have taken the g of both sides. Take the g of p and take the g of g inverse of 1 over 16. So it will just give you 1 over 16, okay? But we know that if g of s is 4 raised to power s plus 3, if we change s to p, what do you think we'll get? That means if we go to the right-hand side, we also change s to p. So g of p will turn to 4p plus 3. But g of p is 1 over 16. It means that 1 over 16 is 4p, 4 raised to power p plus 3. Okay? But we can turn 1 over 16 to a number whose base is 4. Okay? That means 4 raised to power minus 2 by the law of indices. 4 raised to power minus 2 is the same thing as 1 all over 4 raised to power 2, which is 1 over 16. So this 1 over 16, we can bring it to 4 raised to power minus 2. And the reason is because we want it to be in agreement, we want it to have the same look, the same format as the expression in the right-hand side of the equation. So that one at the right has 4 as base. So we just try to modify 1 over 16 to bring it to a level where it will have 4 as a base, okay? Because, multiples of 4 can go in 16. So we have 4 raised to power minus 2 equals 4 raised to power p plus 3. And because they now have the same base, we equate the powers according to the law of indices. We equate the powers, so we have p plus 3 equals minus 2. So make p the subject, just sort out p. P becomes minus 2 minus 3. That gives us minus 5. But, initially we say let p equals g inverse of 1 over 16. So now p is minus 5. What is that telling us? It's telling us that g inverse of 1 over 16 is the same thing as minus 5. I hope that explanation is clear enough. Go back, replay this video, listen and listen and listen over and over again. You will understand, all the details, all the explanation, all the steps, why we take some steps. What's the reason? I explained them, so you can apply that knowledge in subsequent questions similar to this. All right, so that's question number 18. I hope you are enjoying this video. If you find value again in our videos and you want to encourage us to keep doing what we are doing, to keep producing more and more videos, to keep bringing solution to past examination papers, we want to encourage us to do this. Why not subscribe, hit the notification bell, give us a like, share this video, go to the comment section, tell us something about this video, help us to broadcast it so that it will be a joy when we have more and more students, reaching out to this video, and we'll be very happy that somebody is being helped, by our products. There's no joy greater than that. Okay, so let's move on to the next question. That's question number 19, and this is taken from set theory. Here we are given the universal set as a set of numbers 1 to 10, and we are given 3 sets: set P, set Q, and set R. Set P is the set of odd numbers within the universal set. Set Q is the set of multiples of 3 within the universal set. And set R is the set of square numbers also within the universal set. Okay, so we want to find we want to find the intersection between these 3 sets. We want to find P intersection Q intersection R. How do we do that? So we first list out elements of this set. The set of odd numbers, which is P, from the universal set. What are the odd numbers? 1, 3, 5, 7, and 9. These are odd numbers. What about Q? The set of multiples of 3. The numbers that are multiples of 3. Multiples of 3. That is, numbers that 3 can fully divide. So 3 will be acting as their factors. They are called multiples of 3. I can multiply 3 by something to get those numbers. We have 3, 6, 9 within the universal set. Take note, within the universal set given, numbers 1 to 10. And the third set is the set of square numbers. Square numbers within the numbers 1 to 10. What are the square numbers? 1, 4, and 9. Because 1 raised to power 2 is 1. 2 raised to power 2, 4. 3 raised to power 2, 9. Okay? These are square numbers. Numbers that have square root or number that can be written in the form a raised to power 2. All the numbers, the 3 numbers here can be written in the form a raised to power 2. So they are called square numbers. And I want to find the intersection of these 3 sets, or what is common. Which number appears in all the 3 sets? It's only 9. No other number. It's only 9. 9 is in set P, 9 is in set Q, and 9 is in set R. So 9 will be in the intersection of these 3 sets. And that's why we put 9 there. I hope that makes sense. And that is the answer to part A. And we move on to the next one. The B. B is in 2 parts. We have the I, we have the II. Okay? For the I, we are looking for the union of Q and R. So union is bring together, merge. So all the elements of Q join together with all the elements of R. But bear in mind that in set, elements do not repeat. So when we merge, all the elements that appear twice, we just write them out once. Okay, so if you look at all the elements of Q, we have 3, 6, 9. We have 4, 1, 4, 9. Of course, 9 appear twice, so we are going to write it only once. So if you look at the 2 sets, Q and R, they have 3 elements. So joining them together, we're supposed to have 6 elements, but we are having 5 elements. Why? Because 9 appears 2 times, and we can't write it twice. We are not going to have something like 1, 3, 4, 6, 9, 9. No, it's a set. The rule of the set is that all the elements must occur once. If there are 3, 4 times, we just pick them once. Okay, so the union will be 1, 3, 4, 6, and 9, and that takes care of that part. Then the II, the BII, we are looking for the number, that is how many elements are in P intersection Q union R complement. So how I handle this will help us to also understand the concept of complementation. So when we look at, again, we know what Q union R is. We have worked it out in BI, so we know. But what is the complement of this? So the complement of Q union R will be elements in the universal set that are not in set Q union R. So in other words, go to universal set and cross out 1, 3, 4, 6, 9. Cross them out. Delete them from the universal set. If we delete them from the universal set, what we are left with are called the complement. So if we delete from the universal set, if we delete 1, 3, 4, 6, and 9, we are left with 2, 5, 7, 8, and 10. That will be the complement of Q union R. Hope that makes sense. That explanation is down to earth, simple. That's me. I feel that way. Okay? Now, the result that we have, we are going to take the intersection of P and Q union R complement. That is, what is common between set P and set Q union R complement? What is common? Set P, we have 1, 3, 5, 7, 9. Q union R complement 2, 5, 7, 8, 10. So we have 5 common in both sets, and we have 7 common. Those are the two values, 2 elements that are common. So we'll write them down. Now, what are we looking for? The number. That small n outside the bracket represents number. So telling us, go and count. Look at that curly bracket. Count. How many elements are inside? 2 elements, only 5 and 7. 2 elements. Okay, so if you ask me, the number of elements in this set is only 2, 5 and 7. And that gives answer to that question. Hope that is clear. All right. Thank you very much for still sticking with us. So we are moving. We are going up to question 23. Let's proceed now to question number 20. Before we take up this question number 20 again, if you're just coming in, if you're with us and you're thinking, should I subscribe? Please, don't need to think twice. We urge you to hit this subscribe button if you love what we are doing and you want to encourage us. That's a way of partnering with us. Hit that button, give us a like, share this video, go to the comment section, tell us something about this video. Tell us what you feel we need to work on. Tell us how best we can do our video. All right? We really, really, really appreciate that. Okay, so back to question number 20. We have this diagram. All right, looking beautiful for us, the math people, but we feel this looking beautiful. Okay, and then here says that the diagram shows 2 right-angled triangles PQS and RQT. PQR and QTS are straight lines. You can see that? PQR is a straight line, acting as the base. QTS, okay? So it's another straight line. What we are looking for, angle QTR. We are looking for angle QTR. When it's written this way, that is the angle form. When you look at QTR, that's a small triangle. Angle at T. Angle at T. So the middle letter there is where the angle is. Let's say Q to T to R. That angle that is enclosed within the angle formed at that point T. That's what we are looking for. So how do we get that? We try to redraw that diagram and then properly mark the angle that we are looking for and then assign a value theta. Okay, just assign theta and then every other thing is given here. But we are going to use all the things given, to work out what is required. So here we start by saying in triangle PSQ. PSQ, that's the bigger right angle triangle, the bigger one. The bigger right angle triangle that has 18 as hypotenuse. In that triangle, I want to find the opposite, which is QS. QS is the opposite. I want to find it. The opposite, to get it, I will say sine. Remember, for the opposite, you are linking, if you have the angle, so you take the ratio of the opposite to the hypotenuse. Okay, so sine 28 is QS over 18. So I can get QS. QS is going to be 18 times sine 28 degrees. And if you check sine 28 degrees, it's going to give us 0.46947, blah, 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 multiple numbers. Okay, we are not going to capture all the number above. We just take reasonable part of those numbers, reasonable part. I decided to take it up to 5 decimal places, just to increase my level of accuracy. It's better you take 4, 5 decimal places. It doesn't hurt, just to increase the level of accuracy, because we are still using the value for further work. And so when I multiply by 18, it gives 8.45046 centimeters. Good. That is the length of QS. The length of QS. Also remember that part of QS is TS, and that TS is 4 centimeters, remember, okay? But what we are looking for is angle QTR, but let's see how we can get that angle. We now consider triangle QTR. In triangle QTR, we say that the length of QT is going to be the length of QS minus TS. QS is 8.45046, our previous work, minus 4, which is given. If you look at the diagram, TS has a value assigned to it, 4. QT, there is no value. QS, there is a value. We have already found it to be 8.45046. So I can get QT. And QT is the opposite of that smaller right angle triangle. And so that gives 4.45046 centimeters. And we have said that let angle QTR, the angle that we are required to calculate, let it be theta. And so, since we know the adjacent of that smaller right angle triangle, the adjacent is QR, and it measures 9 centimeters. And now we know the opposite, which is QT. We've calculated it to be 4.45046 centimeters. Then we can get that angle T, all right, or angle QTR, by turning that triangle, because that angle is facing up. So that angle will be directly opposite to the line QR. That angle theta is directly opposite. If you draw a line from that theta vertically down, you are going to, come down to QR. So QR is actually the opposite, and QT will be the adjacent. Okay, so we now say tan theta is 9 over 4.45046, and that gives us 2.0222 and several other numbers behind. We just capture this one. So, and then theta will be the arc inverse, okay? I mean the arctan, or the tan inverse, the arctan. So when we take the arctan of 2.0222, that gives us 63.687 degrees. You can check it out on your calculator. Of course, for this exam, the scientific calculator is allowed. You check it out. You see the function key for the arctan. You put it and you key in the number 2.0222, and that gives you 63.687 degrees, okay? But one of the instructions for students preparing to write IGCSE examination, whether 0580 or whatever, check the instruction told that angles are left to one decimal place. Okay, we are to leave angle to one decimal place. The exam body instruction standard for the exam. For Cambridge exams, you leave the angle to one decimal place, and that's why we are bringing our angle now, angle QTR, to 63.7 degrees. And that is the final value. That's the angle we are looking for. And so we've been able to arrive safely. That's good. So I hope this is well explained. You may also need to do a replay, go over it again and again. We understand the concept. All right. So let's proceed. Question number 21. We are to solve a trigonometric equation. Solve the equation 3 tan s plus 5 equals 1. And we are given a domain for s. So s is actually between 0 degrees and 360 degrees. Okay. Okay, that's so it's full quadrant. Okay. All the angles, where the angles will lie, we are going to work out. Okay, where is it going to be positive? Where is it going to be negative? And so depending on what we get, so we are going to solve this equation and see what will tan s give to us, and then we look at which part of the quadrant is it going to belong. So that's things that we are going to look at. So we move on straight to say 3 tan s plus 5 equals 1 as given. Then 3 tan s equals 1 minus 5. 3 tan s equals minus 4. You divide both sides by 3. You have tan s equals minus 4 over 3, which is minus 1.33333 multiple places. And then it's negative. It's negative. And so if it's negative, all right, it means that the angle we are looking for is either in the second quadrant or in the fourth quadrant. I've also made a video. Check out some of my videos where I explain this quadrant. I've made a video where the first quadrant, second quadrant, third quadrant, fourth quadrant, all the ratios, all the trig ratios, the value of the angles, where they are negative, where they are positive. I've made a full video. Go to my channel, search it out. You'll be able to have a complete understanding of this. So for the fact that it's negative, we are going to look at first the acute angle. Okay, where tan is positive, acute angle that will still give us, or the angle that will give us 1.33333, not the negative this time. If we take the tangent of that angle, we get 1.30, so that angle will belong to the first quadrant. Okay, so what we do here is just to assign it. So, okay, let y equals the arctan of 1.33333. We remove the negative. The negative there just to tell us which part of the quadrant is the angle that we are looking for lie. So that's the negative. So we get the acute angle first. And when we take the arctan of 1.33333, that gives us 53.129 degrees. So with this, we will move on. We bear in mind that where tan is negative is second quadrant and fourth quadrant. And in second quadrant, what do we do there? In second quadrant, the condition is 180 minus the acute angle. And in the fourth quadrant, it's going to be 360 minus the acute angle. So we say since tan s is negative, s lies within second and fourth quadrant. And in second quadrant, I mentioned, it's going to be 180 minus the acute angle, 53.129 degrees. And that gives us 126.871 degrees, which, if we write to the expected level of accuracy for angles in the IGCSE examination, we are expected to write all angles to one decimal place. That gives us 126.9 degrees. That's the first value. For the fact that the domain of S is between 0 and 360, so there's still going to be another value, which is the one in the fourth quadrant. So in fourth quadrant, S is going to be 360 minus the acute angle, which is 360 minus 53.129 degrees. And that gives us 306.871 degrees, which is approximately 306.9 degrees to one decimal place. And guys, these are the two values of S that we are required to find. All we just need to know here is the quadrants. Where is it that tan is positive? Tan is positive in the first and the third quadrant, negative in the second and the fourth quadrant. Look out for the video where I explain this thoroughly. It will give you a better understanding. All right, let's move on to the next question. Question number 22, the graph of y equals bracket s plus 2 bracket close, another bracket opens s minus 1 raised to power 2 is shown. So this is a cubic function, cubic graph. And so we are to show that we can rewrite this as y equals s cubed minus 3s plus 2. So just what we need to do is just to expand that bracket. I hope we know how to expand, but if we do not, in this video also, I've taken my time to show how this can be expanded, because that's just what we need in order to re-express what we are given in the form s cubed minus 3s plus 2. And so this is the expansion. So first expand the second bracket, which will give us s squared minus 2s plus 1. And so I will now use element of the first bracket, s, to multiply all the element of the second bracket, and I will use 2 to multiply all the element of the second bracket, okay? And then I will now, add all the terms that are alike. Like here, when I multiply out, I have y equals s cubed minus 2s squared plus s plus 2s squared minus 4s plus 2. So y finally becomes s cubed minus 2s squared plus 2s squared will cancel out, will become 0. Minus 2s squared plus 2s squared will become 0. So we are left again with plus s minus 4s. That gives us minus 3s. And then we have the constant there, which is 2. And that is exactly the form we want to, re-express this function. Okay, so that is done. We proceed to the B question. The B question, we are told that by drawing a suitable straight line, solve the equation 2s cubed minus 5s equals 0. 2s cubed minus 5s equals 0. How do we solve that? Now, what we do, because we have 2s cubed, but our original function is y equals s cubed minus 3s plus 2. When we re-expressed the ones in two brackets, when we re-express, we are going to get a perfect cubic function in the form y equals s cubed minus 3s plus 2. And looking at what we are given, we are asked to solve 2s cubed minus 5s equals 0. And then again, they ask us to draw a straight line. So we're going to do some modification just to get that straight line out. And so we are multiplying by 2. Why? Because I just want to modify. I want to tweak what I have, the original function, or multiply both left and right by 2. It doesn't add or remove anything from the value. because I'm doing it for both sides. I'm doing that because I want to get 2s cubed from the original function. So if I multiply out by 2, the original function becomes 2y equals 2s cubed minus 6s plus 4. If I use 2 to multiply everything, use 2 to multiply y, use 2 to multiply s cubed, use 2 to multiply minus 3, that gives me minus 6. Use 2 to multiply the constant 2, that gives me 4. And then bring the equation given to us, which is 2s cubed minus 5s equals 0. So I just put the 0 under 2y, then every other thing will line up. 2s cubed minus 5s. So I'm going to subtract the second equation from the first. Listen, let me take it again. As I arrange it in this form, I'm going to subtract the second equation from the first. So look at what that will give. So I'm going to do 2y minus 0. That will give me 2y. I will do 2s cubed minus 2s cubed. That will go 0. I will do minus 6s minus 5s. Minus 6s minus, in bracket, minus 5s. That will give me minus 6s plus 5s. That will give me minus s. Then 4, I'll bring the 4 down because under it is 0. So 4 minus 0 is so. Now, when I do this, this is what I'm going to have. 2y equals minus s plus 4. If I write this in gradient intercept form, that is, if I write this final value in the form y equals ms plus c, that is going to give me y equals minus 1 over 2s plus 2. So I'm dividing both sides by 2. So if I divide both sides by 2, I will get y equals minus 1 over 2s plus 2. So the next thing is to draw the straight line, because here we are told that we need to draw the straight line and use it to solve that equation. And so I look at the intercept. The intercept on y-axis is 2. That is, it happens when s is 0. When s is 0, we have y equals 2, okay? And then I just pick another value. I think of another value, like when s is 2, because if you look at this graph, the numbers we can see along the s-axis, the minimum is minus 2, the maximum is 2. So I can pick any of those numbers. So I just look at when s is 2, for example, and I substitute 2 into that equation, it gives me y equals minus half times 2 plus 2. That gives me minus 1 plus 2, and that gives me 1. So if I assemble everything together as points in coordinate form, so the first point will be when s is 0, y is 2. That will form my first point. My second point will be when s is 2, y is 1. That's my second point. So I'm going to use these 2 points to draw a straight line. I'm going to use these 2 points to draw a straight line. So we have, of course, I have, where s is 0, y is 2. And I have where s is 2, y is 1, okay? You may be wondering, how did I get the third point? I just use the first 2 points, that is. So the third point is when I draw the line, it will cut the curve through 3 distinct places. So I just put that circle there to complete. So I will draw the line, okay? And that's the line that we are asked to draw. And then after drawing this line, I'm expected to use this line to solve that equation. What does it mean? Those three places where the line intersects the curve, what are the values of S at these three places? What are the values of S? So here, I'll follow the arrow down to the S axis to look for the values of S at this point, okay? So if I check it using the arrow that points down from those three intersecting points, those points where the line intersects the curve, I take the arrows down to S axis, I'm going to get these values. S is 1.6, S is 0, and S is minus 1.6. Again, the exam body is going to give an allowance, okay? So that some values that may not be exactly this can reasonably fall within the interval allowed, okay? So also make sure that you work hard to make your graph smooth enough, especially the straight line, so that the values you will get will fall within the interval given. So that's it. Hope this is clear enough. You can replay again. And then if you have issues, go to the comment section, chat me up, drop a message, I will answer it. I love to respond. So let's engage. Tell me one or two areas you feel you need to be cleared, okay? And then let's talk. All right, that's good. So I also urge you to hit the subscribe button if you are yet to subscribe, and then help us give this video a thumb up. Share it, give us a like. And then hit the notification bell icon so that each time we drop a new video, you'll be among the first to receive it. Let's look at the last question now. That is question number 23. Are you excited? Question number 23. Let's go there. Question 23, we are given s minus 5 raised to power 2 plus k equals s squared minus p s minus 21. And we have to find the value of p and the value of k. Okay, how do we do that? For this solution, I use one method. Of course, the method I use is expansion method. I just expand and compare. Of course, again, I can write the expression at the right-hand side to look like that of the left, trying around completing the square method, just trying to make it a perfect square, tweak it a little bit, but I just felt this is easier enough because I love using easy approaches to solving a problem. I love easy approaches. Again, I try to encourage students to explore more method. But again, when I compare method, I just try to come up with what is best approach. Okay, so here we expand. We expand and compare. So when you expand the first bracket, that's s minus 5 times s minus 5 plus k equals s squared minus ps minus 21. Then we expand fully. We have s squared. Of course, okay, we use the first bracket to multiply the second. That has been explained before. And then when we do that, we are going to get s squared minus 5s minus 5s plus 25 plus k equals s squared minus ps minus 21. Then I do a kind of grouping here. Okay, I have s squared minus 10s plus, in bracket, 25 plus k is a constant. Is my constant for the expression found at the left-hand side of the equation. That's my constant. For the right-hand side, s squared minus ps minus 21 is the constant. So we now say comparing coefficients. Comparing coefficients, we have, I didn't compare the coefficient, but of course the coefficient here, the s will cancel out. The s will cancel out. And so the coefficient from the left expression, the coefficient of s is minus 10. And so it's either you compare coefficient or you can use the whole of minus 10s equals minus ps. Of course, when you divide by s, it will cancel out. And you still have your p equals 10. Or you divide both sides by minus, you divide by minus s, okay? You have your p equals 10. Again, don't forget that the expression at the left, our constant is 25 plus k. That's our constant term. So I equate it to minus 21. And when I equate it to minus 21, that gives me k equals minus 21 minus 25. And that gives us k equals minus 46. And so we've been able to find the value of p and the value of k. P is 10, k is minus 46, okay? And that brings us to the end of paper 2-1, IGCSE paper 2-1. Here I say watch out for paper 4-1 solutions. Be there, we will enjoy it together. I promise you that. Paper 4-1, we are going to do that together from question number 1 to the last question, step-by-step solution, what you need to do. So if you are with us and you've reached this stage, we say thank you. That's a very wonderful way of learning. We appreciate you so much. You are coming across our video for the first time and you have not subscribed. What are you waiting for? Hit the subscribe button, give us a thumb up, like this video, share this video so that others will have access to it. When you share this video, the YouTube algorithm will be able to show it to as many students as possible. And let's engage. Come to the comment section. Tell us your experience with this video. Tell us how much better we can serve you through our tutorial videos. We'll be glad to hear from you. In the video description, I am going to put down the link to paper 2-1. In case you need it, you can quickly download, use it to go through this video. Next time, we are going to be looking at paper 4-1 together. So let's keep our expectation high. This is Math Minders Academy saying goodbye for now.